Hey guys, today I'm going to explain the natural base E. Here's a fun fact. Scientists use natural logarithms and carbon dating to determine the ages of ancient bones and fossils. So yeah, that's for all those kids that say you're never going to use math in real life. Okay, so first of all, we're going to look at this formula, the compound interest formula, which is A equals P times 1 plus R over N to the power of NT, where A is the amount, P is the principal, R is the interest rate, N is the number of times interest is compounded per unit, and T is the time itself. Now this could be in years or whatever the question requires. Now suppose that you have $1 invested at 100% interest, or R equals 1 compounded n times for 1 year, as presented by the function f of n equals 1 plus 1 over n to the power of n. Now, as n gets very large, interest is continuously compounded. So let's look at the graph of this function, which is right here. So as you can see, the function has a horizontal asymptote. As n becomes infinitely large, the value of the function approaches approximately 2.7182818. This number is called e. Now, like pi, the constant e is an irrational number. Now, they're working with exponential functions with e as a base. They work pretty similar to any other normal functions. So let's try a problem here. Let's try graphing this function. F of x equals e to the power of x plus 2. So the first thing we're going to do is we're going to need a table. Then we're going to need our x values and our y values. So for the x values, we're going to go with -3, -2, -1, 0, 1, 2, and 3. Now, because e is irrational, the table values are going to be rounded to the nearest tenth. So we're going to have 2, 2.1, 2.4, 3, 4.7, 9.4, and 22.1. And then we're just going to graph this like any other function. So here's a graph for that. And as you guys can see, we have a horizontal asymptote just over 2, where it will not pass any lower. And vertically, it will go on forever.